everybody, this is Angie. Today we're going over LeetCode problem 54, spiral matrix. It's a LeetCode medium problem. Let's take a look. You are given an input of a matrix, which is m number of rows followed by n number of columns. And you simply have to return an output array of integers. In this case, it will include every element in the original matrix. However, you're going to return those elements in a spiral order. So for the first example, it's a 3 by 3 matrix. The second example is a 3 by 4 matrix. So the first example has 9 elements. The second one has 12 elements. And you need to return every single element, but in a different order. You want to go in spiral bound order. Let's take a look at the diagram. Okay, let's take a look at the diagram. We're going to have an input of a matrix of integers. In this instance, we will have m number of rows and n number of columns. I like to visualize, when I'm working with a matrix, I like to visualize the arrays like this so that I can actually see the matrix visually. That helps me out. You can also just have the input written out like that. The output is going to be an array of integers. It will include every element in the original matrix. However, we're going to return the numbers in a spiral order. So we're going to go from 1, 2, 3, down 6, 9, to the left 8, 7, back up to 4, and then we'll start going again in that spiral order. So that would bring us to 5. We want to keep track of a few different variables as we're proceeding through this problem. You want to keep track of the boundaries. So the boundaries in this instance will be the top. We'll need one at the top to tell us when we're coming back up, where to stop. So we will stop at this row right here instead of continuing up to the first row. So we'll have to have a way to increment the top row every time we pass so that we don't override the numbers we've already put into the output array. And then we'll keep track of the same thing with the right side. We will want to decrement that each time. With the bottom row, we're going to want to decrement that each time. And with the left side, we're going to increase that each time so that, again, we don't overlap. We want to keep track of the size of the matrix. And you get the size by multiplying m times n, the number of rows times columns. In this case, again, we have a 3 by 3 matrix, so the size of this matrix is going to be 9. So once we have input 9 integers into the output array, that's when we know to stop. That's when we stop iterating through. And yeah, so let's go ahead and take a look. So the first row, it starts off with 1. So 1, 2, 3, very straightforward, go into the output array. 1, 2, 3. And then when you get to the right-hand side, you know that by the boundary is originally set at the size of the first row. So for the right variable boundary, we're going to have matrix 0, which is the first row, and we're going to take that length and use that to get the boundary for the right side. And then every time we pass that, we're going to decrement it. Every time we pass the top, we're going to increment it, because this is row 0, and then we'll be at row 1, and then at row 2. So you want that number to increase each time so you don't repeat. You do the same thing for the bottom and for the left. And then again, keep track of the size and how many elements you've input into the output array, and then you should be good to go. Let's go ahead and code this out. Okay, so we're going to start by creating a list of integers. The list of integers will contain all of the original elements from the input matrix, and we will return the elements in a different order. They'll be in spiral order. We will start off by checking if the input matrix is null, or if the matrix length is 0, meaning there are 0 items in the matrix. And if either of these are the case, we will simply return the empty list. Next, we'll set up the variables. We need to have boundaries for the left side, which will start off at 0, for the top, which will be 0 also. And then a boundary for the right side will be another integer, and that'll be the length of the first row of the matrix. And then for the bottom boundary, we're going to have another integer, and that'll be the length of the original matrix. And then we'll need to keep track of the size of the matrix, which is the length times the width. That will tell us if we have a 3 by 3 matrix, that'll tell us we have 9 elements. And so when we reach that limit, we know to stop inputting numbers into the return results list. We don't want to exceed that bound. Okay, and then we are going to iterate through the matrix. We'll take the size of the list and we're going to compare that to the size of the original matrix and make sure that we're not exceeding the size of the matrix so that we know when to actually stop iterating through the numbers or the elements. So first we're going to start off in the top left corner, and that'll be element 0 of the first row in the first column. So we'll start off at left, proceed to the right, and as long as we haven't exceeded the size of the matrix in our list, then we will continue to increment the iterator. And then as we continue to go through it, we will add each element to the list. For the top row will stay the same, but the top row will stay the same. Each column will increment gradually going from left to right. And then we will take top and we will increment that. So next time we go from bottom to top, we know where to stop appropriately. Then we're going to, now we're on the far right side of the matrix, we're going to go from top down to the bottom boundary. And as long as we haven't used up all of the items or all of the elements in the original matrix, we're going to continue to iterate. And we're going to go through the elements, adding each element from the matrix into the list. The right-hand side stays the same, so that column stays the same, but we're going to keep going down from top to bottom. So the row number will increase with each one. And then we're going to decrement the right-hand side for the boundary. Now we'll iterate going from right, starting at right, and then going all the way to the left-hand bound, going across the bottom of the matrix. And as long as we haven't used up all of the items in the list, then we will continue to go through the matrix and add those items to the list. As long as we haven't used up all the items in the matrix, I meant to say. So we'll add each item into the list. The bottom row stays the same. The columns will decrement. They will go from right down to the left side. We will decrement the bottom so that next time we have the new boundary. And now we're going to go from the bottom of the matrix on the left-hand side up to the top of the matrix on the left-hand side. So that left-hand column will stay the same. We're going to change the row number. And again, if we haven't used up all the items in the matrix, then we're going to continue to add them to the list. And we'll decrement as we go, since we're going from the bottom up to the top, which is a smaller number. We'll add these items to the list. And for this one, the left-hand side stays the same. That will be the same column the entire time. And then we'll increment the left-hand side. Once we've gone around, we'll continue until we've used all the elements. We'll return the list. Let's hit submit. And there we go. If you have any questions, please go ahead and leave a comment below. If you have any requests for a specific LeetCode problem, let me know that in the comments below, and I'll go ahead and take a few requests. Thank you.